Shalom, peace be upon all of you. Today we have this question, and we will do a revision on the previous sections. So let's do that. So here we have the question. It says we have an 50-50 percent by weight of mixture of water and n-hexanol. So we plan to separate this mixture into its constituent and ultimately to end up with an almost pure stream of water and alcohol. So the total flow rate of the H2O and C6OH stream is 100, and also with normal temperature and 2 atmosphere, the flow rate of the C8OH stream is also 1000 kg per hour. Of the pure octanol, we have the octanol, and also we have this hexanol. The hexanol is mixed with the water, and so we're using the octanol as a solvent. So the mixture exists under the condition of the pressure and temperature. The property method we're gonna use is the NRTL, and also we will estimate the missing parameter using the UNIFAC. And the goal is to, as we said, that we end up with pure hexanol, water, and octanol. So in the flash separator, we use the temperature of 25 and the pressure of 1 atmosphere. Let's continue our Aspen process. Let's go as usual. Let's go to the new and to chemical process with specialty chemicals with the metric unit, and we will click on the create button. And so our first step is let's introduce the components. The first one is the octanol, and the second component is the hexanol, and so we have the third component and so we can click on next button, or we can directly go to the meter, or so it's been already selected the method, and so the method is NRTL method. So, and we can go here and we can select the estimate the missing parameters using the UNIFAC. And now the next step is to so still we can click on the next button, or we can go to the simulation area. So in the simulation area, so our objective is to mix these components, the hexanol and the water solution, and to mix with the octanol, and these two are the octanol, and this alcohol is more miscible than alcohol H2O. So they will be mixed, and now we hope to release the H2O using the first two component, equipment. That means let's start with the mixer. So here we have the mixer. So, and the next component gonna have is the flash separator. So let's select the separator in the mixer, and let's see what will be happening after the separation process. So we have two input. The first one is the solvent. That means we have this H2O and octanol. H2O plus octanol, and the second stream is the solvent. That means we have this octanol, but and in the first we have this only so hexanol and the water, and the second stream is the solvent stream is, it has only the hexanol. You can see here the octanol is used as the solvent. So let's go back to our flow sheet, and this is stream mix, octanol, the H2O and hexanol. Here you might have the bottom liquid, from the middle we expect the top liquid, and from the above we may expect the vapor. So the next step is just to feed the given parameters. So we are given with this 50-50 mixture of the solvent is in terms of kilogram per hour. So we have 100 kilogram per hour is being introduced, and also both the solvent part in the mixture is 100 kilogram. And so here we have 25, temperature is 25, the pressure is given with 2 atmosphere, and also the mass flow for the octanol is we have the total of 100, and they share together. That means they share together. So and H2O and hexanol will share the 50-50. So this the total amount is 100 in terms of kilogram per hour. So we can click the next button, or we can directly go to the next or the octanol input area, or you can just click on the next button. So it's the same temperature is 25, the pressure is 2 atmosphere, and the flow rate is 100 kilogram per hour, and so the total amount is 100. Or I can change here. You can use the mass fraction, and I can use the number 1 here for the octanol. So let me click the next button, because the next button is lifesaver. So it will lead us where to go, or the next step we expected, or it will lead somewhere we should fill some parameters. So this one is given that the temperature pressure is 1.9 atmosphere, and the temperature is 25 degrees Celsius, and the pressure is 1.9 atmosphere. So now it says the required input is completed. So now we can run the process, and we can see if the output is 100% of or let's see the product after the separator. So the results displayed. Let's go to let's click on the blog, and let's go to the stream result, and so now we can easily see the mass flow or the mass fractions. So if we see the mass so the octanol, the top liquid is 19.9, and also the hexanol is 49 on the top, and so but we have the higher amount of H2O at the bottom liquid. Let's see the mass fraction. If we see the mass fraction, it's almost 99% of the H2O is separated. But the other thing is if we see the middle output, we have this equal amount of there are a lot of octanol and hexanol. So the next step would be just so we have to choose which way of separation mechanism to use. For example, is that relevant to use the next separator, or is that what can we do to separate these two alcohols? Let's go back to the property area, and let's go to the component, and let's see the parameters. Let's see their properties, and then we will decide which the mechanism, or if we want to use the distillation column or the separator, or if we could use the other mechanism to split those two alcohols, because now we are remain with the octanol and hexanol, but the 99% of the H2O is already split. So to choose the perfect mechanism to separate the octanol and hexanol, so we went back to the component part, and then I clicked on the review, and I'm waiting for the display of the parameters. Now the parameters are displayed, so let's check we can check the parameters, and we can decide which mechanism to use to separate these two components. So here we have the octanol, here we have the hexanol, and here we have the water. So let's see the normal boiling temperature in terms of degrees Celsius. So the octanol is 193 and hexanol is 156, and actually we don't need this one. So maybe just we have a big temperature difference in between hexanol and octanol. So now we can select the maybe distillation column to separate these two components. Okay, before going to the further purification process, let's go back to and let's see if there is an azeotrope or not. Let's search for the azeotropic formation. So let's go to the home and let's click on the azeotrope search, and so if there is we can check if the isotopes are being formed or not in between those three components. So we can click on here the report button. So the isotope search report is displayed. We have the temperature, the boil, and their boiling temperature, and it says the two isotopes found. So in between the octanol and in between the H2O, and in between the hexanol and the H2O. Now we can plot the graph of the isotope, and we can find the point of the place where the isotope is being formed. So here's in the mole basis and in the mass basis. Here's the isotope formation place is displayed. So maybe let's start. Let's see the thermodynamic property. The thermodynamic. Let's see the CP in terms of kilomole, and okay, let's plot the. So we may see the vapor, liquid, and solid CP of these components. So look the graph, how it looks like for solid CP of hexanol, for octanol, or H2O. So